Okay, hey guys, hope you're doing well. So let's see how actually we can become a talented design engineer at any field. Okay, not in engineering, but in many other design aspects. How you can become a talented design engineer before even you graduate from your college. Okay, so let's see how we can do it step by step. Right. So first, these are the important facts and habits that actually first when you step into the undergraduate school, undergraduate studies. So you got to keep it these side things in the mindset. Okay, so you get to have a clear idea about what you're going to be after finishing your undergrad study, right? Whether you're going to do higher studies or immediately you're going to find a job or you got to be a design engineer, right? So I'm currently a mechanical design engineer, so I will focus this video basically on how to become a design engineer and how to create that mindset that will give you some of the unique talents that actually industry wants when they are actually hiring new students for these design engineering portions, right? Okay, so the first thing is you understand that when you are going to undergraduate studies, the things that are taught in the classes are actually not industry oriented, right? Because actually these things actually taught by professors, right? The professors, they actually very rarely actually they are influenced by the industry, right? So they actually do their own research. They actually they have the knowledge. We got that, but thing is they have the knowledge in specifically, right? That's how they do the research. For example, so maybe some professor is doing a research on maybe designing of the screw, right? For example, right? So he knows all the knowledge that regarding that point of view, so he's going to teach others from that point of view. So that's not his fault, right? So there's no one to teach. And so as students, when you're going to go to a design position, right? So we got to understand that industry wants a person to think in holistic view, right? They are not going to give you to design one single part or to do a research on single item, right? So they need that from some, they actually wants from someone that they have that overall idea of how actually everything works, in the industry. So that is we call the design mindset. So the person who's actually designing something, let's say you are designing a screw in the industry, right? So you got to know the application of the screw and how this is influencing other parts of the entire machine, right? So that's kind of thing that you have to understand when just before you start your studies, right? So so let's see how we can create this mindset and how you can actually start designing when at the moment you start your undergrad studies, right? So there are, after that you have 4 years to develop all the skills, and so you can apply to many internships and many jobs in between also. So let's see how we can do it, right? So design engineering mindset. First of all, uh, ask we see how people design everyday things, right? So your laptop, whatever the things, 90% of the stuff we are using at the day, things, everything is pre-designed, right? Somebody designed it and we are using it, right? So we got to be one of the somebody, right? So understand that. So ask the question all the time when you see something is designed, right? So for example, you see, in front of me I have my laptop speakers, I have my mic, right? So I'm always thinking that how they design it, right? How they design it, how they made it a successful product, right? When I see a vehicle and see how they design it, right? So when you ask that question, right, every time when you start working on, so you will find that knowledge, that you will find how to get that knowledge, right? So you are going to dig that knowledge. So so after that, after you get the overall idea of how everything is designed, so you will eventually you will get the skills in coming to you necessarily and accomplish the task that you want actually, right? So so the main thing is, if you have the that my idea is that to start this process, first try to design something that already been designed, right? For example, this is a simple example I can give you. Let's see, you saw uh, vehicle, right? Vehicle engine, right? So you see how that's molded or something that it's actually designed in some way, right? So you just try to design it in that way. and you just try to figure out why something is designed specifically for that purpose, right? So let's see, you see, maybe you see that engine, valves, some valves, and also pistons, they are designed in some way, right? So try to understand why it is designed in that way and try to do your own design. Okay, so design something has already been designed. So in this case, this is the first step. So you will see that your knowledge is not enough to do that, so you will eventually try to dig in. Okay, so that's the first step that keep you above from your friends, right? So I know that everybody do those classes, everybody take the exams, right? Everybody sometimes get good GPAs, right? So that's not enough, so that does not specify you from others, right? So there has to be something more inside you. So that's how this is the first step of doing that, right? And so for example, in this slide, you see that in the left, this figure that this is a power plant that I designed in my first year, because actually I went to a tour on thermal power plant, right? So I saw this complex piping, I saw these turbines, I saw these heat exchangers, right? So it's in my first year, I don't even know thermodynamics, I don't know even heat transfer. So the main important thing is now, but I started design, right? So even though in the first year I know how to do the I know how to design heat exchanger. No one taught me. Okay, I learned by myself, right? I know that in you those complex heat design, I know that, and I know the piping, right? ASME standard piping I know in my first year, because of I started my design. I started my own design, right? Nobody taught me. So this knowledge actually came to me when I was needed it, right? So I think you guys can try this up. This is exactly working, this is not me. There are many talented my friends in there in the valley, and also so they're working different companies. So I think this actually works. Just give it a try, right? And we will see the results very soon, right? So after your first design, after doing the 3D model, and after do the simulation, how everything works, so we will eventually motivated to do another one, right? So that's my first tip number one. So the next one is how to collect knowledge specifically. So so people may not tell you this before, right? So they will tell you first learn the theory, and after that you can go to the softwares and do the simulation. So my idea is totally opposite of that. Okay, I think that first you have to learn the software and become an expert on this, and after that dig into the theory behind that, right? Okay, so how do you, so let's say you are using sorry, well, I'm a mechanical engineer, I don't know about the electronic design perspective, what are the software they're using in there. But for example, we used to use SolidWorks, CATIA and everything, and you used to use finite analysis softwares and everything. So first become expert on this, so you know the keywords in there, right? So you may input these traces and you may use this method, like Galerkin's method, right there, and you see the post processing. So first become an expert on that, and after that you can dig into the theory, so that will make you theory more understandable, right? Because you know the outcome, right? So you know the theory, but you don't know what is the outcome, how everything is visualized. If you don't know that, so there's not a solid understanding of the theory, right? Let's say you are planning to take a finite analysis class in your final year, right? It's better to learn a finite analysis software beforehand and become expert on that, and after that you can apply the theory that you are learning from the class, right? So that will be much more understandable, because you know what are the consequences, right, of this theory, and when to use it, and so more solid understanding. I think you guys are getting this, yeah. So that's how you correct the knowledge specifically. In my next video I'll show you that how you can get the software knowledge, how you can become expert in software, and how you can actually apply those ideas and softwares in your own design, right? So the only thing, you will design your own project. The only thing is maybe you are not able to manufacture it one day, but you just present it. So if you meet the standards of design, if you meet that robustness of that by experience, by doing the same thing, so definitely there is an applicable opportunity that you can actually extend it to the production point of view, right? So these are two tips that I will give you at the moment. So I think this will help. So I wish you good luck and keep start digging. Thank you.